Okay, so today we're going to see the module 4, designing for high availability, section 2. This is the second part of the one that we saw on Friday. And here we're going to see how we can make an environment highly available and with event-driven scaling and serviceless architectures. Okay, so basically we're going to see today, we're going to see auto-scaling, working with some events that trigger that. And we're going to see serviceless in action. Okay. Now, we have here what is in this module: best practices, scalability, determining if scaling is needed, automatic scaling. We're going to improve this architecture and exercise. We're going to see part 4, scaling data stores. And then we're going to see part 5, AWS Lambda and event-driven scaling. So module 4, lab, we're going to see today is, let me see, actually what you guys are going to do is lab 3, lab 4, okay? Because I'm putting the labs based on what we're teaching, okay? This was for another type of lab, but the lab we're using now, it's Vocarian. This was made for quick labs, okay? So upon completion of this module, you will be able to define what is meant by availability, fault tolerance, and scalability, and discuss how those concepts are related and used in cloud architecture. Discuss how to avoid single points of failure, identify which AWS services have built-in fault tolerance and which can be designed for fault tolerance, and explain why load balancing has become a key architectural component for many AWS-powered applications. Okay, part 1 is scalability. So we have here the best practice here. We have an architecture here that we have to ensure that can handle changes in demand, right? And the key advantage of a cloud-based architecture infrastructure is how quickly you can just recover and respond to changes real quick, okay? So here we have the users prevented from access, right? Application servers are full capacity.
Excuse me, Professor. This is Maria. Is this in nearby? Because I'm not able to make my notes on it. It seems
No,
like a PDF.
no, it's
Yeah.
not Nearpod. This, when I've loaded, I'm sorry guys, I should have told you this. When I tried to unload this file, Nearpod wouldn't let me unload it. So what I did, I created a PDF version and I put it on Google Classroom. So if you check Google Classroom, it should be there. Could you guys see it?
Uh, yep. But I'm not able
Yes,
to make. It won't let me make notes on it,
No,
or
no,
yeah.
you have to notes on a notebook or something.
you can download and then you can make a note.
Oh yes, but not online. Okay, I think that one and module 7 have that problem. The rest of them you can use Nearpod. So here the application is it's I think guys, can you hear me?
Yes, we can hear you.
Okay, my computer froze again. I don't know why this is happening so frequently. I will have to restart my computer again. You see my picture? You see my picture? I don't move. So my computer froze again. So bear with me. All right, guys, I'm back. Can you hear me, guys?
Yes.
Yes.
All right, so I'm back. I'm sorry about that. I don't know what happened. You don't know. I don't know. My computer is a 2019 computer. It's a Mac computer that has 32 RAM of RAM, and it has 4 TB of hard drive, solid state drive. I don't know why this is happening. It's a monster. This computer is a monster. And I have no idea, to be honest. So so we continue. I'm going to put this up again. We have here. So we were here. These servers are full capacity. They cannot cope with any more traffic, any more, influx of requests, incoming requests. It can't anymore because, it's just a full capacity, no more than that. Okay. So what happens? The anti-pattern here, what is it? You have to come here and manually provision more servers. Okay, so that's not efficient at all. Okay, that's not efficient at all. In this case, we only have 3 servers, but imagine that you have 50, 60, 70, 80, 100 servers. Can you imagine if you have to come here and create 10 more manually? That's a lot of work. I mean, I guess the administrator should dedicate his time to do something else, not to be manually updating things. Okay, so that's the anti-pattern. Now, this is the best practice, right? The best practice is this. So what happens here? The user never experiences any interaction in accessibility. So we have here application servers, and there's an alarm that is stating autoscaling. Well, if this is a full capacity, what I want you to do, I want you to create more servers for me, okay? And you can establish the amount of servers that you want to create, okay? So new servers ready before capacity is reached, okay? Why? Because autoscaling it's there to help you do that, right? So that's the best practice. Having autoscaling, it is not mandatory, but it's very convenient, right? And it's highly recommended in case you want to be up and running, right? When this happens. All right, so we have what we know in AWS as vertical and horizontal scaling, okay? This is the heading of this slide, vertical versus horizontal scaling. Okay, so what is vertical scaling? Is scaling up or down, okay? So let's say that we need more power in an EC2 instance, so we need a higher instance type, okay? So if we come to here and we have this we create an EC2 instance, right? I don't have anyone right now. Create one, and we come here. We have all the instance types here, okay? So this is what scaling up or down means. Just changing this type, the instance type, to a smaller one or to a bigger one, okay? So we have here, different virtual CPUs, like here 2, 4, 4, 8, 8, all of this. We also have memory in gigabytes. So we have here, different types of memories that we have here. Instant storage, EVS only, VS only. Here we have the big guys, the SSD guys. have if it is EBS optimized network performance, if it is low, moderate, if it is up to 5 gigabits, I'm sorry, or 10 gigabits, or even 100, somewhere there, 100 gigabits, okay? And if IPv6 is supported, okay? So this is what auto-scaling, scaling up, it's all about, okay? So we have also scaling in or out, and this is the one that we mostly gonna talk about today. The one that increments, if it is scaling out, it increments the number of EC2s. And if it's scaling, it reduces the number of EC2s, okay? So here, we have changing specification of instances, memory, more memory, more CPU. So we have small one, and then we're going to an X large, okay? Or vice versa. So we can go from the X large to small one, okay? So now here we have a change in the number of instances, add and remove instances as needed. So we have only one instance here, and all of a sudden we want to have 9, okay? This is based on, traffic, CPU, all that we can specify in an auto-scaling policy, in a scaling policy. Okay, so how do you know if scaling is needed? So don't fly blindly without instrumentation, okay? So to use AWS with an efficient way, you need insight into your AWS resources. So how much of your infrastructure is actually being used? Is your application's performance or availability being affected by the lack of sufficient capacity? So those are questions that you can ask the person you sit with when creating the architecture. Because if you're an architect, you will have to go to the business location and speak to the people that have to do with, the architecting program or something, or whoever is in charge of the business, and explain to them what are the different ways you can design your architecture. And these are two of the questions that you should ask the person, okay? So how much are you using? Okay, how much more do you need? Okay, so how do you capture this information? So this is the guy that helps you capture this information, CloudWatch, okay? Amazon CloudWatch, it monitors your instances and collects and processes raw data into readable, near real-time metrics, okay? It sends notification and triggers auto-scaling actions based on metrics you specify. It turns metrics into statistics to be used by CloudWatch alarms. So you can create alarms in CloudWatch that will trigger auto-scaling, okay? And we're gonna see an example today of this. So CloudWatch offers a distributed metrics gathering system, okay? It collects and tracks metrics. So I'm gonna create here an EC2 instance, okay? All the process again, okay? So I can come here and just select the free tier 1. And here monitoring, I don't want to enable CloudWatch detail monitoring because that's additional charges applied. I don't want that. So I want to stay with the basic one, which is free. Okay. So I'm going to come here, add storage. I don't need to add any storage. I'm going to just right here, I'm going to name it, let's say department. And I'm going to say here, let's say development. Okay. Security groups, I'm going to allow, let's say port 22 is fine for now. Okay. Port 22 is fine. I'm going to create a new security group. Okay. I want to see something here. If this one, that one has 22, no, 22. I like this one. Okay. I'm going to choose this one because it has 22. That's what I need, right? Right. We're going to review and launch. Okay. Everything's fine. I'm gonna launch this. Now, I will need a key here. Okay, because I'm gonna show you how to connect to your EC2 instances, both using SSH or connecting from the console. Okay, so I'm gonna create a new pair of keys. I'm gonna call it my new keys, right? Okay, I'm gonna download those keys. Okay, and I'm gonna put them. You see here. I'm gonna put it here. You see there in my desktop. Okay. So now I'm gonna launch this. Okay. The key is the element that lets me connect to my my EC2 instances using port 22. Okay. So if I take a look at the keys here, key pairs, I'm gonna see that I have. I don't need these two guys anymore. I'm gonna delete it. No, I don't need that. Okay. But I'm gonna use this guy. Okay. This is the one that allows me to connect to my EC2 instances. Okay. So now I can come here. Let me see if my EC2 instance is already running. Okay. I can come here to the dashboard and check. It's already running. Okay. So it's running already. I can either connect from here. Okay. If I click here, connect, and I just close. Let me see here. If I connect and I use this EC2 instance connect here, it's gonna come to this guy. And I'm inside my computer, my EC2 instance, okay? Right? So I'm inside my EC2 instance. This is what we call SSH in your EC2 instance, right? So this is the computer. This is the EC2 instance. Okay, that is using this particular button here inside the console. But what if I want to connect from my CLI? Okay, so I can come here. I can grab the IP, because the IP address, the public IP address, is the one that lets me SSH into my EC2 instance. So I can come here. I can open the terminal. I don't like this terminal. Let me change the terminal. Okay. Windows may vary. This is for Mac. Okay. I'm gonna open it again. And now boom, is different. Okay. So I'm going to SSH into my instance, but now I have a problem. This guy here doesn't have permissions to access it. Okay. So I have to use, in Linux, I have to use this chmod. Okay. I have to use this guy, and I have to use the permission patterns, right? And I have to put, well, actually before that, I have to be in the desktop. Okay, I'm in desktop now. Okay? I have to be in the directory where the file is. Okay, and how do I do that? Using the command cd. Okay, cd. That takes me to the directory I want to be in. So I give cd desktop. Okay, and then I am in the desktop now. Right. So I can come here and use chmod, which means change mod, right? And I'm gonna give you permission so I can use this file. So the name of the file is my new keys.pem. Okay, that's the extension, 10, right? Now if I hit enter, it already had permission. Okay, now I can use the file. Now, for SSHing, I have to use the SSH command. Okay, SSH command. I have to use the option I, the name of the file, and then put the user, EC2 user at and the IP address. Okay, now if I do this, there you go. I'm inside the computer. You see there? It's the same thing as we did here. Okay, it's right here. Same thing, you see? But here, I'm accessing my computer or my server from the console, right? Right here, I'm accessing the computer or the server from the CLI. Okay, do you guys see the difference? Now, here, I can install anything I want, okay? Which we're gonna do later, right? So do you have any questions? No questions? Okay, let me see a chat. Nope. Okay, no other questions?
Nope.
Okay, so we are SSHing into our EC2 instance through port 22. If port 22 is closed, we can't do this. Okay, we can't do this. But we can do it here using the keys. The keys are the ones that give us access to the EC2 instance, right? Which was the file was created. If I lose this guy, or I delete it, I cannot access the EC2 instance anymore. Okay.
Can you recreate it? Can you download it again?
You will have to, no. You cannot download it again. So if I come here to the keys, there's no way to download it. There's no way to download it. You have to create another one. But, you know, if you create another one, I'm not sure if it creates a file for you. So I recommend whenever you create an instance, keep that key. You know, keep it. Put it in a safe place. Okay? It's a pain to be able to use other keys if you lose the one that was downloaded. Okay? It's like if you lose your password, the password of your computer, they will have to do something weird to be able to access the computer. Very weird. Okay? It's the same thing. The keys are the ones that give you, because inside this file, there's a public and a private key. Those are the ones that give you access to this particular EC2 instance. Okay? Now, the good thing about this is that I can use the same keys for other instances. Okay? The only thing that I have to do is when I create another EC2 instance, right, I have to choose the key. Okay? So I can create another EC2 instance. And then when I get to that point where I have to, you know, let me see here. When I get to the launch part, I can choose an existing key pair, okay? And then I can choose the ones that I created. And this one, don't forget that this one is here, okay? This one is here, okay? It's right there. That's why when you get to that last part of the EC2 instance creation, you're gonna see that you have that choice to select this because this is already created here. It's in the console. All right. So as long as I keep this guy here in a safe place, I can use it for any amount of EC2 instances. Okay, as long as I choose that key, and during the last process, the last part of the process of installing or creating an EC2 instance.
So it's a good, let me see if I understand this. So these keys pair with one and multiple EC2 instances, or is it a one-to-one relationship to the keys?
No, when I created the instance here, when I get to the last step, I have to choose a key or create key or proceed without a key. I have the three options. So what I have to do is select the one that says choose an existing key pair.
Okay, so you can use a key for multiple EC2s.
That is correct.
Okay. So if you were to, oops, sorry.
Yes.
So if you were to use multiple keys with the same, no, sorry.
It's only one.
They said, no, never mind. I was saying it incorrectly. If you were to use the same key for multiple EC2s, can you go back to the console for one moment to your command?
Yeah.
Where? No, the
command line.
Yeah, this one.
I can SSH into another EC2 instance using the same keys, but I have to choose those keys at the end of the creation of the EC2 instance.
Oh.
Okay.
Oh, there you go. EC2. No, that's a user. Oh, for this, that's for the IP address. I got it.
That's the IP address, the public IP address of the.
For the EC2 instance, right? For that particular one.
Correct. So we have here. If you come here, if I select the one that is running, I have here this IP address, which is the same as this one.
So if you had another EC2 instance, which means you will have another IP address.
Correct.
Then you will SSH to it with the same keys, but the user part will be a different.
Yeah, the IP address will be different. But don't forget, you have to choose the key at the end of the creation of the EC2 instance. When you create a new instance and you go all the way through the end, I'm not going to change anything, just all the way to the end.
Okay.
And I review and launch. Here is the section where you choose the key.
Okay.
I prefer to go with an existing key pair. That's why I choose this one. But I can create a new one. And name it anything I want and download it. Okay, so this one will be only effective with this EC2 instance because that's the one that I chose at the end. Okay, or I can choose the one that I have now, and then that's okay. I can use it for this instance. This is the part when you tell EC2 instance, this is the key that I'm going to use to SSH into you.
It makes you acknowledge that. Look at the bottom. It says, I acknowledge that I have access to the selected private key and that without this file, I won't be able to log into my instance. So that's it tells you better keep them.
Yeah, without the key, you cannot log in. Okay, if I exit, right? If I exit and I do this, you see the same command again, and I remove the key, something is missing, right? And if I put a key, any name I want, this is my key, okay? Any name I want, I'm just making it up. Look at that. Identity file, this is my key, not accessible, not such file or directory. Permission denied, because it doesn't have a key, right? Permission is denied. But if I use the same as I used before, there I am, I'm inside. You see? So I can run sudo yum update. Sudo, what it does is it elevates my privileges to an administrator. So what I can do is yum update, and then I can update my EC2 instance. Okay, you see this question? You guys see this question here? Is this okay? You see it?
Yep.
You see this question? It's because I didn't do this. Okay. Okay, yes, it's okay. Okay. If I do this, that's going to say yes to every question. There you go. The question is not asked anymore because I'm telling yes. You see? It's updating my EC2 instance. Okay. Okay. So it's updating there. I can wait until it updates everything. Okay. I think that this was part of your lab, right? Or no? You didn't have to. You guys didn't have to SSH into your EC2 instance in the lab? No? Yes? Maybe?
For this class or the other class?
For the morning class. No?
Not the lab.
Okay. So this is the end of this. It's complete. You see? It updated everything that I needed to be updated. All right. So I can continue here. Okay. Let me see one moment. Okay. So Amazon CloudWatch offer integration with AWS Identity and Management and Unified CloudWatch Agent. Okay, so we have CloudWatch alarm examples, Amazon EC2, if average CPU utilization is more than 60% for 5 minutes. Amazon RDS, if number of simultaneous connections is greater than 10.1 minutes. And Amazon ELB, if the number of healthy hosts is less than 5 for 10 minutes, then create another one or do whatever is necessary. So these are type of alarms that you can create with EC2, not EC2, with any kind of services here with CloudWatch. Okay, you can do that in the alarms. So CloudWatch alarms and actions. CloudWatch alarms, you can measure a single metric and perform one or more actions. So you can stop, terminate, reboot, or recover an Amazon EC2 instance. You can scale an auto-scaling group in or out, or you can send the message to Amazon Simple Notification Service, SNS. Okay, so let's create an SNS topic. So we can come here, SNS, right? And I'm gonna create a topic. Okay, create topic. So here we're gonna call it my very first topic. Okay, in this case, I just give it a name, just a generic name. But for example, if you want to receive a message from Lambda, you can say my Lambda notification. Okay, you can give it a meaningful name, right? But so far, I just wanna give it a name, the name that was before. Okay. Very good. Okay. And I'm just display name optional. This is optional. I don't want that. Encryption is optional too. You can have encryption here, enable encryption for that particular notification. I don't need that. Access policy, you can have advanced. This is what a policy looks like. Okay. So it's a JSON file. It's a JSON file. JSON JavaScript object notation, right? That has a key value pair. Key value. Key value. Key value, key value, key value. You see? All the key values. Okay. You can have deliver retry policy just in case you want to retry. Like how many times you want to retry? 3 times. Okay. Status, deliver status logging, if it was delivered or not. Okay. Tags, if you're going to you name, any name, and then you create the topic. Okay. Now, when you have the topic, this is my topic, my very first topic, and it has an NRN. NRN means Amazon resource name. Okay. Amazon resource name. This is not name, number, sorry. Amazon resource number. So it has, well, actually, let me see. Sometimes it's confusing. Amazon resource name. I was correct. So Amazon resource name. This is the, sometimes when you want to connect one service to the other, this is the guy that is used for that. Okay. It has a topic owner. That's me. This is my account number. Okay. My account number that you can find somewhere here. I think it's a support center where you find your account number. It's right here. Okay. That's me. My account number. Okay. I am the owner of this topic. I created it. Right. Remember, you may have several users and several accounts. Remember when we say organizations, right? When we say organizations, you may have several accounts inside your organization, okay? Inside your root account. So you have to create a subscription, okay? What is a subscription? The person that will receive this notifications, okay? You can send it in different formats, HTTP, HTTPS, email, JSON, all that. I'm gonna send email, okay? So I'm gonna say here, dunieski@gmail.com. Okay. And there's one service that I think is there's one service, I don't remember well now, but there's one service that people use. It is free email. It's a public email that you can use to test. And you don't have to use your personal email. Okay, I don't remember, it's Mailton or something like that, Mailton. I don't remember. Okay, something curious. This AWS is built using React. You see here, when I just click on this extension, it says this page is using the development build of React. Super interesting. Okay, if I come here and inspect this website, so I can see here that they have the source is React. It's right here, React Developer Tools. Okay, I have build here. The console elements, they have all this HTML tags here, memory, application, okay, security audits, and components. These are the components you're using here, the components of React. Super cool. How do you know that? I hadn't seen this before. Like, I never had the curiosity of seeing what language is AWS built upon. Nice. So the subscription filter, if you want to have any subscription filter here, I can create the subscription. Okay, subscription is created. What I have to do now, it says pending confirmation. I have to go to my email. And then my email, I see AWS notification. And then I confirm this, right? And now you have subscribed Dunieski Otano to the topic, my very first topic. Your subscription ID is, this is the Amazon resource name right here. If it was not your intention to subscribe, click here to unsubscribe. I don't want that now because I may use this topic in the future. Okay. So that's how you create a topic. Okay. We can use that for later. I just have to identify that topic and that's it. Okay. Cloud design pattern monitoring pattern. So we have here CloudWatch, right? that monitors this thing here. It has an elastic load balancer, and then the elastic load balancer is in front of 4 web servers, right? And then the web servers are accessing the database, right? Which is, you know, you can have a database in EC2 Instance as well. So you can have a database on top of RDS, or you can have a database on top of an EC2 instance. The only difference is that if you have the database on top of the RDS, RDS is managed by AWS, so you don't have to worry about anything that is on the line there. But if you create your database and EC2 instance, it's like having a database installed in your computer. You will have to work on this, okay? You will have to do probably the managing and the patching and all that for that database engine, okay? So this is not recommended completely, okay? It's better to have RDS. This is a managed service, but you have the choice to choose a managed or unmanaged service. It's your choice. All right, so we have this here. We're obtaining monitoring info from API and save all these metrics. We can have monitoring software as well that monitors this. So CloudWatch can monitor this directly, or it can have another software that monitors that that architecture here. All right, so CloudWatch, tough guy, monitoring metrics, okay, of your resources. Like I said before, this guy's gonna be with you your entire life, okay, CloudWatch. Store and monitor application log files with CloudWatch logs, okay? You can have CloudWatch logs where you can have all the, you know, the metrics and all that. My God. So we have logs. Oh my God, one more. So we have logs here, Amazon CloudWatch, CloudWatch logs, and then you have batch process, batch archiving, console for the data processing solution, batch process, Amazon S3 to archive those logs, and admins to the console. Guess where you're gonna store the logs from CloudWatch? Huh?
S3.
S3. So admins and other parties review CloudWatch logs directly via AWS Management Console, or logs can be stored in Amazon S3 to be accessed by other service or another user, okay? Logs can be streamed in real time to data processing solutions like Amazon Kinesis, Streams, or AWS Lambda. This is more for the developer exam, but it's good that you know that, guys. It's good that you know that when it says real-time data processing, real-time Kinesis, okay? Amazon Kinesis. Now, auto-scaling, typical weekly traffic at Amazon.com. So we have there, as you can see, it's very steady, right? I mean, the peaks is always there every single day. Sunday, Monday, Tuesday, all the days. Provision capacity. You know, it's like what do they call it? EKC, electrocardiogram. It's what they call it. It's similar to that.
EKG.
I'm sorry?
EKG.
EKG, okay. EKG. So provision capacity, the challenge is to efficiently guess the unknown quantity of how much compute capacity you need. So you see here, November, 24%. It's you know, then when it gets a little later in the year, or probably the new year, you see it's higher. So it's hard to determine that, okay? So auto-scaling is the guy. It's the guy that helps us with that, okay? So we can have either 24 or 76%. You see, this 24 here is being used, but there's a 76% that is not being used, right? So how can you determine that? How can you gauge that? There's no way to do that until it happens, right? So what you can do is use this guy, okay? It's the guy that launches or terminates instances based on specific conditions that you can set. automatically register new instances with load balancers when specified, and you can launch across availability zones, okay? Now, do not guess resource needs, okay? Don't guess. Say no to guessing. You know, one of the benefits of AWS cloud is that we can stop guessing our capacity needs, and then just we can let AWS do whatever needs to be done by using autoscaling. Autoscaling is the guy, okay? So if you want to have high availability, this is the guy in conjunction with Elastic Load Balancer, okay? They work together and they are a good team. They make a good team working together, okay? Now we have CloudWatch here and with an alarm, okay? So the alarm is set the way you want, okay? Based on CPU usage, right? If it is EC2, if it is an RDS, you can have an alarm based on connections, how many people are connected to the database, right? So here we have three web servers or three EC2 instances, right? And three EC2 instances. They're all of them, they are accessing here the master database. I think we saw this architecture before, master database. And then we have a standby database here that is not doing anything. It's just receiving information. And every information that is written here is being written here synchronously, okay? So everything that comes here is written here, okay? Synchronously, almost instantaneously, okay? And this guy's gonna be, just in case a disaster, something happens, something bad happens, it's gonna fail over to this, right? And this is the guy that's gonna take charge, and then it's gonna continue the process that this one was doing until this one is fixed, okay? So this is basically it. Now, autoscaling, don't fear constraints, right? Avoid limiting the ability to create new resources on demand with just-in-time and or scheduled provisioning, okay? You can do it, you know, right at the moment, or you can do it, you can schedule that, okay? You can have a schedule policy. How can you make this happen? Through the APIs, scripts, and autoscaling. You can create autoscaling from the console, okay? Not from the console, but you can create it from the CLI as well, okay? From the CLI. There's a command for everything in AWS. So autoscaling CLI. There you go. So here we have a lot of commands, okay? Create autoscaling group. So you can come here and check here, create autoscaling group, right? You can say autoscaling group name and give it a name, launch configuration name, okay? Because an autoscaling group has two steps. First, you have to create the configuration, and then you have to create the autoscaling group, okay? So you can have the instance ID, right? You can have the minimum value. When they put here this inside square brackets, it means that you're gonna have, or you may have more than one, okay? This is what we call in programming arrays, okay? You can have more than one, okay? In the case of a name is only one, that's why you don't have the square brackets, okay? Whenever you see this square brackets, it means that this value may be more than one, all right? Minimum size is only one, maximum size is only one, okay? You can have the site capacity, and all this, and then you can create the autoscaling group, okay? So right now I think I have only one instance right now, okay? Instance, right? I'm gonna leave this way and I'm give it a name. Let's just give it a name. Well, the name is department. Let me change that. Let me edit this name. Let me put it here, name. So I can see here, okay, name. Department, let's say dev, that's development. And let me put here, department, okay? So I save it now. Now I see here, you see? Why do I do this? Because I don't want to be confused when I have other EC2 instances here, okay? So what I'm gonna do now, I'm gonna create an autoscaling group, but I'm gonna do it first. I have to do launch configuration, okay? I have to create a configuration. A configuration is just, the skeleton of the autoscaling group, and it's basically creating the skeleton of an EC2 instance. This doesn't create an EC2 instance, but it gives autoscaling the skeleton, okay? So I'm gonna choose here the same AMI, okay? You see, I think this looks familiar to you. It's the way you create an EC2 instance, okay? So we have configuration details. I'm gonna call it my first launch configuration. I don't need a role now. This, if I want to create spot instances, I can choose this here, right? But I don't want to create a spot instances right now. I can enable CloudWatch detail monitoring for all of those instances that we would create from this configuration, but I don't need that, okay? So it says here later, if you want to use launch configuration, a different launch configuration, you can create a new one and apply it to any autoscaling group. Existing launch configurations cannot be edited, okay? Very important. If you want to make a change later, you will have to create a new one. So you have to be sure of what you're doing right now at this point before you continue and do this. Remember when we created the EC2 instances, we had a section where we created an Apache server, okay? If I want to create an Apache server for all the instances that are created with autoscaling group, I can put it here. And every single instance that is created with autoscaling, we have this configuration. That's why it's called launch configuration, okay? So if you want a service that has identical EC2 instances, that's autoscaling group, okay? They are exactly the same as what you create here in the launch configuration, okay? So I'm gonna go to storage. I don't need to do anything with this. The security group, I'm gonna choose the one that has both port 22 or port 80. I think it's this one. Perfect. We're gonna review it. Right. So I'm gonna create a launch configuration. You see here, I'm choosing my key. That's the one that I'm gonna choose for all the instances, right? So here I'm gonna say launch configuration, okay? Now, this is the first step. Second step, we have to create an autoscaling group. So we come here and we say my first autoscaling group, okay? So we're gonna start with 3 instances. That's gonna be my start point, okay? I'm gonna start with EC2 instances. I'm gonna choose, for example, this subnet, another subnet, and another subnet, okay? To make it more available, right? And the VPC is gonna be the default one. I haven't created any VPC other than this one. So we're not gonna use a load balancer right now. The health check grace period is 300, which is 5 minutes, right? Instance protection, I don't want to protect from scaling. I don't want that. I want it to scaling just in case, but I have to create a policy for that, right? Then I'm gonna go configuration details. I wanna keep this group at the initial size, right? The initial size is 3. Or I wanna do this, I'm gonna scale between three instances and whatever, but I just keep it this way, okay? So we can continue here. We can add a notification here, okay? Remember my very first topic? Remember? I can choose this when my EC2, whenever instance is launched, right? or terminate or fail to launch or fail to terminate, I want to receive an email. Okay, so I can continue here. Tags, I don't need that now. So so we have group size 3, minimum group size 3, maximum group size 3. Okay, so I'm gonna have 3 all the time. And auto scaling, I'm gonna receive an email, my subscription that I have here. And then I can create auto scaling group. Okay. So I have the auto scaling group here. It's gonna create 3 instances for me. You see here? It starts with 3 instances. Okay. They're state of pending now. Okay. They're healthy. They're showing healthy, the status, but we have to wait until they are fully created. If I come here to the EC2 dashboard and I see here, I have three more instances that were created with the auto scaling group, right? And I have 3. This is the one that I had before. That's why I named it. Okay. And these are the other 3. There's one that's still pending, right? So right now, there are 3 in service, right? So by any chance, if I just delete one of those 3, it will delete. I will deregister that one, and it will create another one for me, because that's the minimum capacity that I need is 3, and the maximum is 3. Okay, so it's right here. I have 3 instances right now, desired 3, minimum 3, maximum 3. Okay, I can change the maximum to 5, right? If I want to. Right? So I can do that if I want to. Okay? But for the moment, let's keep it this way, right? Let's keep it this way. And let's add later probably an auto scaling policy here. Okay. So, you know, maybe here later, we're gonna do this later. Okay. For the time being, let's continue with this PowerPoint. We just created an auto scaling group. And first we created a launch configuration and then auto scaling, right? So how does auto scaling work? So what and where, right? So we have AMI. That's what we create, what we use to create instances. It's a machine, an Amazon machine image, right? And it's also the template that we use to create EC2 instances, right? It's a template that contains everything that we need to create an EC2 instance. So we have here, we create an EC2 configuration, launch configuration. So what do we need? It defines what? The name, the AMI, instance type, user data, just in case we want to install something at runtime. We have security groups, IAM role, and etc. Whatever else we need, tagging, or you know, whatever you need for this launch configuration. So then we have to create the auto scaling group. That's what we just did, right? First step, launch configuration. Second step, auto scaling group. Now, auto scaling group defines what? The name, the launch configuration that we're using, right? In this case, we didn't have to specify the launch configuration name because the auto scaling group was linked. It was just a button right after we finish the launch configuration. It means that it's a link to that. But let's say that you create a launch configuration and then you just go and come back to the console like 2 days later, and you want to create an auto scaling group, then you can select this launch configuration and create the auto scaling group. Okay, so you can have a minimum and max size. You can choose the AZ or subnet. You can choose a load balancer, and you can choose the desired capacity in whatever whatever else you need. 3, you can have an auto scaling policy, specify when to increase, when to decrease, increase or decrease Amazon EC2 instances based on CloudWatch, alarms, or you can schedule actions, tell auto scaling to perform a scaling action at a certain time in the future, minimum, maximum, and desired size for the auto scaling group. So you can have 2 ways. You can use an auto scaling policy, or you can have a schedule action. Okay. This is just up to you guys, whatever you want to choose here. Okay. But basically, this is a high-level explanation of how auto scaling works, right? 2 components that you need for auto scaling. It's a launch configuration, which gives you the template, the skeleton of that auto scaling group. So every single instance that is created with this launch configuration is going to be exactly the same as all the parameters that you specify here in the launch configuration. Okay. And then the second part is auto scaling group. And then the third part is to schedule it or create the policy for it. Okay. So that's the load balancing, CloudWatch, auto scaling, just working together, all of them working together. So we have the elastic load balancing here, right here. We're working with these guys. Okay. Right. So it's like a loop here. Okay. So let's say that auto scaling is telling CloudWatch that the latency is very high. So what you have to do is just with this CloudWatch through a scaling policy to
Sorry, I cannot hear you, Professor.
I'm sorry?
I cannot hear you.
You cannot hear me?
Now I can. There is there you
Oh,
go.
there's someone I think I muted already. The person that was okay. Perfect. Can you guys hear me? The rest of the class?
Yes, I can.
All right, good.
Yes.
Okay. So there's a high latency here. So we're telling CloudWatch, please create some more instances for me. It's just the way it works. The 3 of them together, working together. Deciding minimum capacity size, auto scaling group defines desired capacity, minimum capacity, maximum capacity right here. Desired capacity, minimum capacity, maximum capacity. Okay. I wonder maybe I can say 5 here. And maybe the desired can be 4. Okay. Let's see what happens. So we have desire 4. The minimum is 3, and the maximum is 5. Okay. So now, probably in a few minutes we will have another one because that's the desired capacity. Sometimes it takes a little. Okay. So we can come back to this later. So what would be a good minimum capacity to set to it? Okay. What do you think is a good minimum capacity? Use your knowledge, the one that we have acquired so far in this class. What do you think should be the minimum capacity? Hey guys.
Maybe two. Sorry, I was talking on mute.
Okay, good. 2 is the minimum capacity. All right. You see here? You see how it changed the desired capacity? So right now I have 4. You see how auto scaling works? I have 4 EC2 instances right now because I changed the desired capacity, right? If I delete 2, it immediately creates 2 for me. Okay, because it would always keep to the standard. I mean, adjust to this guy here. Okay. And what would be a good maximum capacity? Can I have some answers? What would be a good maximum capacity?
70%.
70%? Well, it all depends on your business, right?
Right. Right.
It's very subjective, right? So how about high availability? Okay. So what about the high availability? If you require at least one instance per availability zone to start with, the minimal capacity size should be set to the number of availability zones. So we have 2 availability zones, so we need 2. We have 3, it should be 3, okay? So that's the standard, okay? We shouldn't have any availability zone with anything inside, okay? But with nothing inside. You should have something inside, and that's an EC2 instance. All right, whenever you see this little square here with this little thing here, like graphics, that's CloudWatch, okay? That's CloudWatch. So we have here EC2 instances, and this is CloudWatch, right? The case
do you have a way of getting all those symbols in some sort of a document or something?
From where?
A document that has all the symbols and what they mean?
Let me see. I think that this is taken from the AWS documentation. Okay. Let me see something. I think that I would have to do that. I don't know exactly where these pictures were taken, but I can do that for you guys. I can take a screenshot of that particular section, and I can put it on the document. All right, not a problem. I can do that.
Thank you.
You're welcome. So here we have this guy here, right? So we have our last load balancer here, working with these guys here, right? So minimum 2 instances, right? Because we have 2 availability zones, right? The desired capacity is 2 instances minimum. Why? Because we have 2 availability zones, right? We have 3 availability zones. The minimum capacity is 3. We have 4. The minimum capacity is 4. So we should have at least 1 per availability zone, right? But availability zone without anything inside, that doesn't make sense, right? It's paying for nothing, right? So that's the best practice, right? 1 per availability zone, okay? And AWS recommends having 2 instances minimum, right? And two per availability zone, and 2 availability zones minimum, okay? So we're always gonna start with 2, no matter what, okay? That's what we have to do, okay? So here in this scenario, CPU use triggers the alarm, capacity is double until CPU utilization drops below 60 or max capacity is reached, right? So we have CloudWatch here working here, right? So auto scaling group, minimum 2, maximum 12, right? Minimum 2, maximum 12. Why do we have minimum 2? Because we have 2 availability zones, right? And the maximum is 12, 4, 4, 4, 4. So we have 12 here. Auto scaling policy, when CPU use is greater than 60%, add 100% of the group. So double the capacity, okay? So we're telling this guy that if it is 60%, so we don't want to have this guy here. So we're gonna have like 4 more, okay? So the minimum capacity is 2, we're gonna have 4, okay? We're not double that. That's why we have these 2 here available, okay? So that is what happens. It adds the minimum capacity to 4 more. So this is what you tell autoscaling, okay? This is what you tell autoscaling. Like this, for example, now, add 2 instances when average CPU is 80, between 80 and 100%, right? So we're gonna scale out. So add 1 instance when average CPU is between 60 and 80. Remove 1 instance when average CPU is 20 to 40. And remove 2 instances when average CPU is between 0 and 20%. So the minimum is 5 instances, the maximum is 20 instances. Now, when we say remove, what we have to put is a negative number, okay? For adding is a positive number, and for removing is a negative number, okay? That's how the scaling works. So as usage increases, CPU use goes up. So when CPU use is between 60 and 80%, scale out alarm is triggered. So the alarm that we created with Amazon CloudWatch, it scales out, right? It add 1 step policy, add 1, the one that we saw before, the add 1, right? Right here. That policy, it's applied. A new instance is launched, but not added to the aggregated group metrics until after warm-up period expires. So whenever an EC2 instance is added, there is a period between the moment it's created until that warm-up period expires, okay? So then it can be aggregated to the group metrics, okay? So whenever you hear this 1 more period, let's say that you create a new instance, but right after that, you don't see the metrics of that instance, the answer is that it is still going through the warm-up period, okay? Very important to understand that. There's a small transition there, a warm-up period, when you don't see any metrics of that particular EC2 instance, okay? That will be visible when the warm-up period is expired and it has been aggregated to the group metrics, okay? Now, as usage increases, CPU goes up. So while waiting for the new instance, CPU use remains high. Another alarm period is triggered. Since currently capacity is still 10, during the warm-up period, and desired capacity is already 11, no additional instances are launched, okay? So with this scaling policy, you can specify the number of seconds that it takes for a newly launched instance to warm up. So you decide how long that warm-up period is gonna be, okay? So an instance is not counting toward the aggregated metrics of the autoscaling group until after its specific warm-up time expires. In this case, because the current capacity is still 10 during the warm-up period, and desired capacity is already 11, no additional instances are launched. So you may have instances when you don't need to launch anything because you have another policy in place, and there may be an alarm period, and I'm sorry, and 1 more period, and in between that, the moment it creates the EC2 instance until it's aggregated, we don't need anything for the autoscaling, so we don't create anything. So while scaling out, we do not consider instances that are warming up as part of the current capacity of the group. Therefore, multiple alarm breaches that fall in the range of the same step adjustments result in a single scaling activity. This ensures that we don't add more instances than you need. So you may have several scaling policies in place, right? And during that warm-up period, Autoscaling may realize that you don't need any more. Okay, so this is something that you don't have to worry about. Autoscaling does that for you. Okay, but we have in this case here, we have 0, nothing was added because the capacity was already 11. So the desired capacity was already 11. And the capacity right now is still 10, right? But the desired is 11. So we don't need any more EC2 instances. And it may not, it will not add anything. So here we have another one. When CPU use is 80 to 100%, scale out alarm is triggered, add to step policy is applied right here. Add to right now, the first one. And then since the alarm occurred during a warm-up period, 2 instances are launched less than 1 instance added during the first alarm. Okay. Again, new instances are not added to aggregated group metrics. This may look a little confusing, but this is the way that auto-scaling works. In that time, when there's a warm-up period, there should be other, there might be other alarms that are triggered, and then auto-scaling realizes that the initial 2 that you were, that you scaled to be, that you set to be added, they don't need to be added, okay? The way that you originally said it. So as capacity matches usage, CPU use stabilizes. So when CPU use is 40 to 60%, no alarm are triggered. So after warm-up period expires, new instances are added to the aggregated group metrics. So the key here is if there is any alarm in between, okay, during that warm-up period. In this case, there was nothing. Nothing was triggered. So the instances that were supposed to be added are added to the aggregated metrics. Here we have when the CPU uses 20-40%, scaling alarm is triggered. Remove 1. So an instance is removed from the auto-scaling group and from these aggregated group metrics. Of course, you know, when you have 20 to 40%, you know, your business doesn't need to have 2. Okay, so 1 it would be removed. Okay, and when CPU is between 0 and 20, scaling alarm is triggered, and then you're gonna remove 2. Okay, remove 2 of the 10 original that were there. Okay, or actually of the 9, because you have 10, and then you remove 1, and then you remove 2 more. All right, so 2 instances are removed from the auto-scaling group and from the aggregated group metrics. Okay, so this is something that is logical, you know, as your CPU usage goes down, less instances you need, right? Now, when it is greater than 40% and less than 60%, no step adjustment is triggered, so no step policies are applied, no instances are added or removed from the service. This is another one that you can have, another policy, okay? Right, auto-scaling considerations, avoid auto-scaling thrashing, okay? We're more cautious about scaling in, avoid aggressive instance termination, scale out early, scaling slowly, okay? Yes, you don't have to do it drastically, okay? Scaling little by little, but scale out early, okay? To just be able to cope with the demand and traffic, okay? Set the minimum and maximum capacity parameters, values carefully. You have something that you have to think ahead and then, you know, analyze with other developers or other AWS experts and the business owner. Be careful with that. Study the business, the trends, the traffic throughout the year. at a particular moment in during a particular month. So you have to be careful with that. Use lifecycle hooks, very important. Perform custom actions as auto scaling launches or instances terminates. So we can have some lifecycle hooks here that you can create, launch the instance or terminate the instance, whenever, heartbeat, timeout, default, abandon, continue. This is something that you can have in the middle of a creation, just in case there's one EC2 instance that doesn't go through the health checks. Then you can abandon that and then check what's wrong, and then you can say continue, and then the creation continues. So this is good for troubleshooting, okay? So auto-scaling lifecycle hooks enables you to perform custom actions, and auto-scaling launches or terminates instances. For example, you could install or configure software on newly launched instances or download log files from an instance before it terminates. So you can here, just in case you want to terminate an instance, right? What you're gonna do is abandon, right? And then you can install something, get some information, some log files from that instance before it terminates. And then after that, you can change that to continue, okay? And the instance will be terminated by auto-scaling, okay? So that's what lifecycle hooks is, okay? And the lifecycle of an instance is creation, warm-up period, and it is aggregated to the metrics, right? That's the life cycle, and then terminated when CPU is low, right? Based on the policy that you created, right? We have a scaling policies here. Now that's life cycle hooks. Don't forget that, okay? Stateful applications will require additional automatic configuration of instances launched into the auto-scaling groups, okay? We talked about this before, applications are needed. So, EC2 instances are disposable. Once you use them, you can remove them, but there's some of them that are important, and those need additional automatic configuration. So that's something that have to be specified. So, an auto-scaling group has instances that can be treated as stateless, okay? Stateless means that we don't care about the state. We create them, we remove them, we add them, we just terminate them. We do whatever we want, and they're stateless, okay? But stateful ones are important. So that's something that you have to consider when creating instances with auto-scaling, okay? So let's improve this architecture before we go ahead and have the break. Okay, what do you think is missing here? What do you guys think is missing here? Okay, what do we have here? Oof. What is the meaning of that, Brian? Oof.
I don't really know, like just glancing at it once. Like it has the replication, multiple forms of availability.
Okay. Remember we saw this before?
CloudWatch.
We saw this before in our last class. We saw exactly the same graphic, right? Okay, so what is missing here is CloudWatch. Very good. CloudWatch to monitor the health of the elastic load balancer. Okay. And also the instances, right? And what it does is it launches actions appropriately. Okay. So we're missing CloudWatch. What else are we missing?
Auto-scaling group.
Auto-scaling, correct. So we're missing both CloudWatch and auto-scaling. Okay. There you go. It looks more horrifying now, but it's we have a CloudWatch here, right? CloudWatch here, CloudWatch here, right? And we have the Autoscaling group here as well. So these guys are in a group, okay? And these guys are in a group too. So we have a NAT gateway. We continue with the same architecture as before, right? We have a NAT gateway or NAT gateway or a NAT instance, right? But if you want to be highly available, we use a NAT gateway, right? Okay, guys, this is it. This is it for now. So guys, we will be back here in 10 minutes. So that's gonna be 2:41. Okay, I have a 10 minutes break. Okay, guys, we're back. So I want you to give me a thumbs up if you're there.
Here.
Good. How are you feeling today? Do you feel that you're learning?
Oh, yes.
This is a little bit more, I will say, complicated.
Who's Maria? Yes.
Yes.
Do you mean compared to the morning class?
Oh yeah, definitely.
Oh yeah, it's a different whole level.
Mm-hmm.
It's a whole different level. Yeah. And as you go further up, it's gonna be more complicated. The same services, still more complicated. Well, actually, not the same. Well, the same and many more. Okay, as you go up in the complexity, it's gonna add more services that are related to that particular certification. So my recommendation after this one, go for the developer if you want to take another one. Okay, and after that, you can go for the CSOPs, and after that, go for the professionals. If you wanna be ambitious and get the certification for AWS, don't go straight to a professional one. You know, go through all the associates first, and then the professional is gonna be much easier.
In developer, you have to learn the programming language.
No. It's developing in AWS. They don't assess any coding, anything. It's just that you have to know how to use the developer tools, like
Okay.
code commit, code deploy, code build, code pipeline, of those guys. Lambda, and API gateway, DynamoDB.
Is that going to be part of this whole series of classes, or
No.
that's
No, the solution architect doesn't focus on that particular section. No. What it does is high availability more than anything. Okay.
No. I'm talking about the classes that like this one.
I wish.
No.
Okay. I wish, but I'm not sure about that. I have all the certifications for that. So if you're looking for an instructor that is certified, I have them, but the class has to be available. And also, I think that a minimum requirement, the person should know all related to the cloud partitioner, and also some knowledge on developing,
You mean coding, programming?
Understanding, you need to understand DevOps, how DevOps work, development and operations. You understand that concept, okay? Because you're gonna be working with all of that, operations and development, okay? Developing is not only coding. It has to do with a series of, concepts behind development.
Are you talking about does it go through the whole cycle, requirement?
No, it doesn't.
Architecture, all that?
No, it's not. It doesn't focus on architecture. It's developing. Okay, developing, because every certification focuses on something different. Even though they use the same services, but you're going to see CloudWatch from a development perspective. You see CloudWatch here from an architecting perspective. Different things, right? Because CloudWatch isn't everywhere. If you see CSOPs, you're going to see CloudWatch in a different phase. It's a different phase of CloudWatch. It's CloudWatch for administration of a system. Everything is different, right? Everything is different. The same service, but different perspectives. Okay. I don't think developer is a difficult exam. For me, it was the easiest one, and the highest score that I got was in developer. For other people, it's more difficult. but it doesn't require any development, any coding knowledge whatsoever. You need to understand the development process, okay? But you don't need to code for this exam. When you hear the word development, well, people think it's coding and programming. No. It doesn't have anything about coding. It has to do with coding, but it doesn't focus on coding. Okay.
We're talking about the engineering of it, right?
The engineering is this one more than anything. That one is for development. Like, how do you develop? What are the resources that you use for development? Like, how do you create a pipeline? How do you save the code on AWS? And how do you use that code to build the application, to deploy the application using last image stock or CloudFormation? It focuses heavily on CloudFormation. CloudFormation, because CloudFormation is the tool that developers use to develop, right? So you need to understand a template in CloudFormation. You don't need to know any programming languages, but you need to know how to write a template in CloudFormation that uses YAML. If I show you a YAML file, for example, if I show you a template, let me show you a template in CloudFormation. Let me see here. One moment. Okay. So this will be how you create an EC2 instance with CloudFormation. Okay. So you have here resources. The name is my instance. The type is this one. It's a instance, an EC2 instance, right? The properties is gonna be availability zone US East 1. The image ID is gonna be this one. And the instance type is gonna be this one, the T2 micro. So basically we're doing exactly the same as we do in the console, but we are creating with code. And this is called infrastructure as a code. We're using a YAML template, YAML, right here.
Is this an Amazon configuration?
No, this is VS Code. Remember VS Code?
Okay.
What I asked you guys to download the first day. So this is VS Code. And then you're gonna go to CloudFormation and upload that in CloudFormation. Okay. In CloudFormation, you load that code, right? So we create a stack. And then in the stack, upload the template. We upload the template here. I think it's called CloudFormation. CloudFormation right here. So I'm gonna upload this here, right? Then is it good? Can you read this?
S3.
S3? Okay, so we were able to see this file from S3. Okay, so next we're gonna give it a name. I say my EC2 stack or CloudFormation stack. And then we can do next. Nothing else here. Okay, we can do next. Estimate the cost. Let's see what do you think they use here? Single monthly calculator, remember? Okay, so from June 30, we will no longer support the single, and then we're gonna use the pricing calculator, okay? I don't want any of this for now. I don't care about the cost because I'm gonna delete it as soon as I create it. So I create a stack and it says create in progress. It's gonna take a short time because we're only creating an EC2 instance, right? So if I come here to the event and I refresh it, you see that the instance is started to be created. So create in progress, right? Create in progress. And I didn't specify any security group. It's gonna use the default one, okay? the one that comes with the EC2 instance. Resources, you see, is creating the EC2 instance. If I come to the EC2 console and I check the dashboard, you see there is one that is being, it is initializing here. You see, it's creating that one, right? So CloudFormation is create complete, you see? It just created an EC2 instance for me with code. You see how easy it is? It's super convenient. We just put the code here. And if you want to create another resource, you can say security groups, you know, security group. My security group, that's the name. And then you can start putting properties here, okay? And then it will create a security group. I can run the same template, but what's CloudFormation gonna do? It's not gonna create this, right? It's not gonna create it again. It's already created. What it's gonna do is update it. Just put the security group and create it, okay? So this is, we're gonna do that probably in one of the classes when we get to automation, right? So because this guy is super important for developers, okay? You can create everything. So you can create virtually everything in AWS using CloudFormation. Autoscaling, elastic load balancer, policies, IAM users, IAM roles, anything, you name it, is done there. Lambda functions, API gateways, DynamoDB tables. You can create anything you want with CloudFormation. Is it helpful? Yes, it is. Okay. So this is basically it. Now, if I come here and I delete the stack, if I delete the stack, it will roll back. It will delete everything that it was created. Everything that was created, it will delete it. So if I come here to the EC2 instance, you see, it's shutting down the EC2 instance. So when you delete the stack, it deletes every single thing that you created with that stack, with that template in CloudFormation. Okay. So it's super convenient and it's happening that way. Okay. I hope you like it. I love it.
Yeah.
I love it. But you have to understand CloudFormation. Okay. And you have to know the different sections of a template. In that case, we use only the resource section, which is the one that creates the resources. But we have conditions, we have outputs, we have parameters, we have mappings. So there are different sections of the CloudFormation template. But the one that is mandatory is the resources section, which was the one that we just used. Okay. Amazon Auto Recovery, EC2 Auto Recovery replaced impair Amazon EC2 instances automatically with Amazon EC2's Auto Recovery feature. So a condition detected by CloudWatch that caused an instance to be impaired, loss of network connectivity, loss of system power. These are reasons why an instance will go impaired. Okay. In other words, unhealthy. So we have replacement instances, maintain same ID, metadata, IP addresses, cannot use in-memory data from impaired instances. That data is lost, whatever it is in, there's like your computer in the RAM memory is lost because it's in memory, right? So you have to have a snapshot in place so that you can snapshot your EBS volumes and save that data. Okay, so continue here. Currently supported instance types for EC2 Auto Recovery. It only supports certain instance types like C3, C4, C5, M3, M4, M4, M5, R3, R3, T2. You see T2, we are in the T2, right? T2 micro, right? And X1. these are the big guys, right? The big guys, these guys, except T2, right? T2 is still big, but we're using T2 micro. The word says it, micro. But these are the big guys for the big heavy duty applications. So we're not interested in that. We just need to know that for EC2 auto recovery, it needs a specific type of instances, right? Availability in every AWS region, that's pretty good. That's highly available, right? Instances must be in a VPC and use shared tenancy, okay? So whenever you create an EC2 instance, right? You get to the third step after you choose the type. There's one section here that says tenancy, okay? Tenancy. You can have dedicated or dedicated host, right? We are using, so far we've been using shared. So for you to be able to have an auto recovery EC2, you have to have shared tenancy, okay? I hope you guys understand the meaning.
What do you mean share? What do you mean share?
Okay, that is not dedicated. It's not dedicated.
Who are we sharing it with?
Okay, whenever you create an EC2 instance, it's running on a hypervisor. Then the hypervisor has a lot of instances. You're sharing that. Okay, so when it's dedicated, it's only for you, not for anyone else. So we say here share versus dedicated tenancy.
Mm-hmm. In AWS.
Mm-hmm. Okay. So shared tenancy means that multiple EC2 instances from different customers may reside on the same piece of physical hardware, right? The dedicated model means that EC2 instance will only run on hardware with other instances that you've deployed. No other customers will share the same piece of hardware as you do. Okay, so I'm gonna put this in the chat. Okay. I hope you guys are falling in love with AWS as we go, because I mean, that's my experience. AWS is beautiful.
Well, I like AWS, but this is showing actually a better side of also AWS, but working with the guys at AWS have been amazing.
Mm-hmm.
The professional services group, it's amazing.
Yes.
I just like how cheap it is and that you can kind of put theoretical to practical very quickly.
Uh-huh.
And let me tell you a secret. High paid. Highly paid.
That's even better.
Yeah. The cloud pays better than many jobs. All right.
What is the starting?
I'm sorry?
What is the startup?
The starting, it depends on your experience. But
Zero experience.
No experience, probably 45, 50. But it could go all the way up to 180.
It depends what you're gonna be doing, you know.
Yeah, it depends on the
your job.
If the more responsibility, the better you get paid, right? But you have a lot of responsibility. And let me tell you something, you can get up to $180,000 a year. And even more. I've seen salaries of 250 for data analysts. You know, it pays well, really well. But you have to work your back off. So instance storage cannot be used. You must use elastic-backed storage exclusively. So you have to have an EBS volume, okay? Instance storage is when you don't have an EBS volume, okay? So you have to have, you have to back your EC2 instance with an EBS volume, okay? Instead of auto-scaling where your job needs to maintain identical instance instead use auto-scaling when your job needs to maintain identical instance metadata or storage volume. Remember, when you create a launch configuration, all the instances are going to be identical. All the instances, whatever EVS volume you use for that instance, the other instances are going to use the same, exactly the same configuration of that EVS volume. So what it does, it creates a different EVS volume. It's not using the same. Remember, you can only use one EVS volume for one EC2 instance. It is creating another EVS volume for every single instance, okay? But it's going to be exactly the same configuration. Okay,
You know, oh, sorry. Can I ask a question?
Go ahead.
When you were creating EC2s before, they go from micro to whatever, large, extra large, and so on, right? So there is a column that says EBS. There is another column that says SSDs.
Where's the
column? And you're gonna have to go back to where you create an EC2 instance. And I was asking myself, what is EBS versus SSD versus HDD? Because I thought EBS was the higher level, and then you either have SSDs or HDDs.
Oh, that's on the third page?
Right here. No. Go back. Okay, right here. You see where it says instance storage GB? Okay, so it says EBS. And I thought the only two types or four types. It's the SSDs right there. What is EBS only? What does that mean? See, it says SSD. Now keep going down.
Yeah, I know what you mean.
Maybe Elastic Block Store, that one?
That's what it is.
Yeah, but Elastic Block Store is a type. And then underneath that, that's what we saw this morning, right? You have SSDs and you have HDDs.
Oh my God, one moment. Okay. Let me check the EC2 documentation.
So right there, type.
Okay, yes, but let me see something here. This is the instance type. Okay.
EBS optimized. What does that mean?
EVS only.
I don't want to take you off your
schedule
class, but you know, it's curious. I'm curious, what do they mean by that? You know.
Oh, we have to find out. That's a good question. What is EVS only? Elastic Block Store provides block storage. EVS volumes are attached. I don't know what they mean with this. All right, I'll find that out later. If you find the information, share with the class, please. That's a good question. You got me off guard. That's
No, this
yeah.
is a shared learning opportunity. So
Yeah. Yeah, good. I have this marked on my calendar. I have to check that. Okay. So auto scaling data stores, so scaling databases. With scaling on Amazon RDS, you can scale up or down with resizable instance types. Databases also have class types. They also have this R thing or X thing, instance types too. Scale your storage up with a few clicks or via the API. Easy conversion from standard to provision IOPS storage. You can also use EBS for databases. Okay, offload read traffic to read replicas, and for increased performance, put a cache in front of RDS, such as Amazon Elastic Cache for Memcache or Redis. Your preferred cache solution self-managed in Amazon EC2. Don't forget this guy, Elastic Cache. That's the guy that you use to cache the information from the database. All right. So you put them in front of them. All right. So Redis is for high-end applications. Is it for high performance applications, high performing ones, and Memcache is less performing. Not as high as Redis. All right. Elastic Cache has two different deliveries: Memcache and Redis. Okay. And Elastic Cache is for RDS, right? Scaling Amazon RDS with what is this? So, RDS writes with sharding. Okay, sharding is like partitions, right? Partitioning of a database. So without shards, all data resides in one partition, right? When you have different shards, you have different partitions where the data can reside. And of course, the more shards you have, the more available you're going to be, right? So instead of having one shard, one partition, which is becomes a hot partition when it has a lot of requests to that particular partition only. So if you have several shards, it's going to be offloading the database, so it's going to be better performance for the database, right? So with sharding, split your data into large chunks, shards. Example, users by last name A through M in one database and N through Z in another database. So you can have several databases. And here we have an Amazon RDS, right? And then you can, it's much better to grab the names from here from 1 to M and the names from here from N to Z. It's much better for performance, right? Performance. Sharding is important for performance. So in many circumstances, sharding gives you high performance and better operating efficiency, okay? In many circumstances, it doesn't mean all of them, okay? It depends on what you need, right? So this is a technique that database administrators can use for maintaining their data highly available, okay? So this is the way that you create horizontal scaling with read replicas, right? Read replicas. So this is very good for performance. Above everything, read replicas, what they help is in performance, right? If you want to help with high availability, I don't know if you remember when we I show you how I just presented you with the first page to create an EC2 an RDS instance. Remember what I told you about the production account? What includes? Remember? What does it include? There's one section there that I told you, this is only with the production, with the heavy tier, with the free tier, it is not available. Do you guys remember? Does it ring the bell? The bell? Multi A, multi-A. No? Am I talking to myself? Multi-A? Multi-AZ, remember? Multi-AZ. You can use that to have your data replicated to another zone, right? That improves availability. But if you want to improve, don't forget this. If you want to improve performance, read replicas. Performance, read replicas. Multi-AZ, we have a master database. Remember, master database. And we have a standby database, right? The standby is not doing anything. It's not doing anything until the master goes down, right? And then it will fall over to the standby. So it improves high availability. Say availability, it improves that. But in the case of performance, read replicas, why? Because the read replicas are constantly working. They're not in standby. They're constantly working, but you cannot write on them. You can only read. That's why it's called read replicas, right? But the only disadvantage is that the replication with read replicas happens asynchronously. So it means that there might be some delay between the moment the data is written in the master and the moment when you can see it available in the replica. Okay, in the case of a multi-AZ, the replication is synchronously. In the case of read replicas, asynchronously. So it's not right away. It will take some time for the data to be available. So that's what some people call eventual consistency, that you don't see the data right away. It would take some time. So if we access the read replica right after the data is written in the master, we may not see that data in the read replica yet. So we will have to wait a little bit. Okay, so that's the difference between multi-AZ and read replica in high level. Multi-AZ, it improves the availability. Replication is synchronously. Read replicas improves performance, and the replication is asynchronously. Okay, happens asynchronously. So current available for Amazon Aurora, MySQL, Maria, this is for you, MariaDB, PostgreSQL. Okay, so these four are the ones that can support read replicas at the moment. Okay, and Amazon Aurora is proprietary of Amazon, right? This is Amazon owns this, but the other ones are not from Amazon. Okay, MySQL and Postgres are from Microsoft, all that. Okay, so scaling Amazon RDS push button scaling. Scales nodes vertically and up or down, right? Scaling, horizontal scaling with read replicas, read heavy workloads, just in case you need to improve performance. Scale nodes vertically up or down for micro to 16x large and everything in between. This is the way you scale up, right? That's the way you scale up. Horizontal scaling, which is scaling out, right? Scaling out. What do? You create a replica, right? Scale vertically, often with no downtime. So this is downtime, sorry, not downtown. So when you change the instance type, this is very frequently super fast, okay? It doesn't have a downtime, right? Now scaling horizontally may have some downtime because you create replicas, okay? So it may take some time to create a replica. Autoscaling for DynamoDB. So we have another tough guy here, DynamoDB, super heavy duty database. I love DynamoDB. If you come here to services and you just write DynamoDB, so we can create a table, right? We're gonna name it my DynamoDB first table. Okay, partition key, let's call it, for example, ID. All right, it's gonna be a string. So you can add a sort key, okay, just in case you have a date, for example, and you want to print all these IDs here, sorted by key by date. You can use this guy. Usually, a sort key is a number that changes, and it has a chronological order, usually. Okay. So I can come here and just leave everything as default, as it is, and then it begins to create a table. It should be fast because it doesn't have anything. So here, if I come, okay, I can add create an item. I can send ID. ID is, for example,
Name.
001.
Oh.
And then I can add here, I can put here name.
Mm-hmm.
And then I can say Dunieski, right? I can have here another name, say H, 12 in my dreams. Okay, so I can say save, and there you go. You have the first item here.
Oh.
Okay, so now you can write a Lambda function that brings everything here. For example, just in case you want to write a Lambda function and create a function and then put the code inside. Okay. You can go online and check, for example, code or Lambda function to fetch data from DynamoDB. You have a video here. Retrieve item from DynamoDB. Okay, so we can create here. It's already created. And then maybe, so, okay. Oh, this is using API gateway. That's something different. Using Lambda, DynamoDB string record here. If I come here and see the function, so somewhere here, where's the function? No function. Give me a function. Okay, just give me a function here. But bottom line, you can create a function that brings the data from the database and print it, and then you can use that with the UI, a GUI, graphical user interface, and bring it to a website if you want to. But that takes a little thinking, and you have to work on that. But this can be printed using a Lambda function. Okay. Good. Something that you can do here, it's I think that action manage ETL, for example. It's going to take 1 hour. What it does, TTL, what it does is you can schedule this, for example, this column to disappear in a month, for example, because you're not going to use it anymore, right? You may continue.
Excuse me, Professor.
Go ahead.
I'm gonna have to head out. I have an exam now at 3:30.
Good luck, man.
I'll watch the video after you post it, but thank you.
Good luck.
All right, thank you.
All right, so DynamoDB monitors throughput consumption using Amazon CloudWatch alarms, right? and then you will adjust provision capacity up or down as needed. Amazon Cloud, DynamoDB, AWS kind of, you can have some auto scaling as well there with this guy. So default for all new tables and indexes, right? Auto scaling is default for all of them. So this guy, what it does is it scales automatically, okay? And it's a heavy duty database, but the database has only one table. That's what amazes me about DynamoDB. It's only one table, because usually when you say in a relational database, you have several tables that are related to one another, right? And even though some of them are not related to one another, but you have a bunch of them that are related, right? Through a primary key and a foreign key, all that. But in this table, or this database, there's only one table. That's absolutely crazy. When I saw this in the College Board and they showed me the table, that was crazy. Imagine the SAT is taken by millions and millions of people around the world. So all the data of those million people are shown in that table, in that one table. That's absolutely crazy. So case study, the Peak Games, we had to provision servers through email and wait 4 to 6 hours. If there was a problem, we had to manually import all the backups to new servers, right? So for your information, Peak Games is the largest and fastest growing gaming company focused on the emerging markets of Turkey, Middle East, and North Africa, okay? So they're not just some companies, it's a heavy duty company for gaming. Big Games, based in Turkey. It's a gaming company with 25 million players across the Middle East and North Africa. In 2011, they were using a co-located server solution and could not keep up with the managing, scaling, backups, provisioning, and setting up new servers, high availability, and disaster recovery. Needed to avoid a large upfront investment for new servers and wanted greater scalability for unpredictable game launches. Okay, so in other words, they were screwed. Okay, they were doomed. They had no, I mean, it was a lot of work to be able to keep up with this, capacity demand. That's absolutely crazy. But thank God they knew about AWS. Okay, and they knew that the solution to their problem was to move to the AWS cloud. Okay, so they said here, whenever we launch a new application or game, we first determine the AWS services that we can use. So which greatly reduces time to market and DevOps overhead. We then scale our infrastructure based on the load. So, two different scenarios. Here we have a problem, man. If there was a problem, we had to manually import all the backups to new servers. We have a problem here. Now we don't have a problem. We are in good hands now. Okay? You know how much money they're saving right now? You have no idea. All right. So Peak Games uses Amazon EC2 in auto scaling groups. There is guaranteeing that they are highly available, right? They're using Amazon RDS with MySQL for storing data. They're still using RDS, relational database system, right? They have Amazon S3 to store backups and game assets. Amazon S3 is going to be everywhere. They're using Amazon Elasticache to improve performance of their web applications. What do we put Elasticache? What do we put it in front of what? What do we put it? Guys, what is Elasticache used for?
CloudFront?
Databases. CloudFront is something else. Okay. CloudFront is a global content delivery service. This is for RDSs, right? It's a little bit closest to RDS than CloudFront. CloudFront works mostly with S3. Okay. Elastic load balancing to distribute the traffic across applications, right? And Amazon SNS for internal applications, example, to push marketing notifications directly to users. Okay, so these guys are using all of these musketeers to accomplish a highly available infrastructure and to save tons of money, okay, with the AWS cloud. Okay, so take a look at this when you have some time and see some of the main components that you use for a highly available infrastructure. Okay, this guy for servers. If you want to be a little more sophisticated, you can use Lambda. Lambda, right? Lambda auto-scales automatically. It scales automatically. You don't need auto-scaling for Lambda. But you can use RDS for, MySQL. If you need more capacity, if you need more power, you can use DynamoDB, right? S3 is a good guy for backups. Amazon Elastic Cache, you can use that for that. If you have DynamoDB, you can use DynamoDB caching, right? Elastic Load Balancer, this guy is super important. Is the one that sends heartbeats. Health checks to see if there's a heartbeat somewhere, okay? And we'll be using only the healthy instances. And we have this guy to get notification emails of whatever events that happen based on what you set before, okay? So benefits, big games. We're developing new games constantly. Thanks to AWS, our DevOps team can set up the infrastructure for our new games while supporting our existing games. Okay, so it's much easier now. It's more automated because DevOps is all about automation. Okay, and we have many less headaches. Okay. So this is great, man. I don't know what else to tell you. This is the best decision they made. All right. And as you can see here, they don't regret it, right? They're happy instead. So by moving to AWS, Big Games reduced provisioning time from 6 hours to 10 minutes. Can you see this? Can you believe this? Can you believe your eyes? It took them 4 to 6 minutes to provision servers.
That's
4
crazy.
4 to 6 hours, right?
That's insane.
And now that it takes 10 minutes. So downtime here was too high. The downtime here is only 10 minutes. So they're saving money. They're giving the users a better experience, a much better experience, and they are getting more reputation. The company's more reputable now when they switched to AWS. So autoscaling their game and data layers allows them to handle sharp changes in demand over the course of a day, because users use their games at a particular time during the day that maybe the demand is high, but you have autoscaling. Okay, you have autoscaling. You don't have to worry about that, right? They also reduce time to market by 75%. as well as cut operational costs and staff needs, while increasing flexibility, game availability, and scalability. Okay, and flexibility, people can work from home, right? Because they're working in the cloud, right? The good thing about AWS and anything that has to do with the cloud is that during this coronavirus thing, you don't lose your job, okay? So the cloud is the present and the cloud is the future. We are not subject to any situation like this one. Anything that happens in the physical world doesn't affect the cloud unless there's a disaster in the data center, right? But we can still work from home, and thanks to the cloud, we have Zoom, we have this class, right? So these guys, they had that vision, and they study and they researched. I'm sure they researched AWS, and then they decided that that was the best bet for them. Okay, and they didn't regret it. Okay, now they're super happy with this, right? Any questions so far? No?
Yes.
Yes, sir. Go ahead.
What kind of application works with relational database like DynamoDB?
What do you mean? What kind of application?
CRM, human resource.
No. Are you taking the morning class?
Yeah, of course.
Okay. Yeah. When we get to databases, we're gonna see when to use RDS, when not to use IDS. Okay. So there's some do's and some don'ts when it comes to RDS. Okay. It all comes down to your needs, to your business needs, right? DynamoDB is serverless. It doesn't need a server, right? It's a fully managed database system, right? DynamoDB. It uses DynamoDB. It doesn't use, and it's no SQL. It doesn't use any SQL database. So for DynamoDB, you have to use other third-party things like GraphQL. I don't know if you have heard about GraphQL.
Yeah.
Have you guys heard about GraphQL? So you can use GraphQL for that. You can use Lodash. Have you guys heard about Lodash? It's a JavaScript library that is used for the database as well and for retrieve information. Now for RDS, you will use 6 types of engines. You will use either Postgres or SQL Server, all those guys, right?
RDS is different. RDS is different. It's based SQL based.
Yeah. It's a SQL.
Yeah. Oracle, SQL Server, MariaDB.
It's a SQL database.
Dynamo.
It's a SQL database. Okay.
Okay. Another question. The Elasticsearch works with DynamoDB or only relational database?
Mostly with relational databases, with RDS. Okay. DynamoDB has its own cache service. You see here.
Okay. Thank you very much.
So DynamoDB uses the DynamoDB accelerator. It's an in-memory caching for read-intensive workloads. Okay, so this guy is expensive as hell. Okay, so you know it's called DAX too. DAX. Right? That's a DynamoDB access accelerator. Okay. So Elastic Cache is mostly for RDS. Right. And DynamoDB is a whole different dimension. Okay. It's like being in another world. Okay. And more efficient and more elegant world, but a more expensive one too. All right. It's like living in, it's like living in probably living in Kendall or living in Coral Gables, something like that, or probably living in Miami Beach or in Brickell, something like that. There's some companies that need DynamoDB for sure. Okay. So Lambda, fully managed compute service that runs stateless code. Okay, Lambda it's serverless too. Serverless. Okay, it's a fully managed compute service that you can use Node.js, you can use Java, Python, C#, .NET Core, and Go. Okay, you can use all these languages, right? It responds to an event or on a time-based interval. If we have time today, guys, I'm going to show you how you create a cron job, how to stop an instance at a specific time, and using Lambda and using CloudWatch, right? So it allows you to run code without managing infrastructure like Amazon EC2 instances and auto-scaling groups. So Lambda scales automatically, right? No, the trend right now is it's in a way towards making EC2 disappear and use Lambda. Okay, so that's trending right now. Serverless is trending. So I don't know how near in future, but someday Lambda will completely replace EC2. Of course, they have to improve Lambda, because right now the execution time for a Lambda function is 15 minutes. So it means that if your application needs more than 15 minutes, Lambda is not the guy. Okay, Lambda is not the guy. But there's a solution. You can use something called step functions. Step functions. That is part of the serverless architecture. And these guys, you can run several Lambda functions together. It's like it's a workflow of different functions together. So that will give you the opportunity to run several Lambda functions one after the other. Okay, but if your application needs more than 15 minutes to run, Lambda is not the service for that. Okay, that's the disadvantage that Lambda has. I'm sure that they will improve it in the future, but so far, no, that's the way. So AWS Lambda handles servers, capacity needs, deployment. It handles servers. It doesn't mean that it needs a server. It means that when you trigger a Lambda function, I can work with the server. And I'm gonna show you the code to stop a server with the Lambda function. Okay? You can deploy, you can trigger deployment using the code pipeline. Deployments with Lambda function, you can scale and fault tolerance with Lambda function. You can do some updates of the operating system of a server and of the language. You can have some metrics and logging with Lambda. Lambda enables you to bring your own code, even native libraries. You can do that too. Run code in parallel. You can have several codes running at the same time with Lambda. Create backends, event handlers, and data processing systems, and never pay for idling resources. If your Lambda function is not working, you don't have to pay for it. You only pay when Lambda is running, okay? If it is not running, it's just free, right? Very important. How can AWS Lambda be used? Scaling events can trigger AWS Lambda functions, right? I can tell, for example, CloudWatch, tell Lambda to, when CPU instance it's 20%, tell Lambda to stop the instance, okay? And Lambda will go ahead and stop the instance. You have to write that code. You have to, for Lambda, you have to have knowledge of coding. You have to have it, because Lambda is a function, and a function has to be written with code, for sure. Okay, so code run in AWS Lambda has access to the AWS API and can be granted permissions via the AWS IAM roles. A Lambda function has to have a role that allows Lambda to interact with other services, okay? This is something that you see in the basics of AWS, okay? This course already assumes that you know about roles, okay? A role is nothing else than giving one service permission to interact with others, okay? And then you create a policy which is inside this role, a policy that allows, for example, Lambda to interact with EC2 instances. For example, if we create code to stop an EC2 instance, I have to give Lambda a role that allows Lambda to have access to the EC2 instances. Otherwise, Lambda, when it goes to interact with the EC2 instance, I'm going to stop you, EC2 instance, I'm going to stop you. Then when Lambda checks that there's no role for that, it's going to tell you, hey, I am missing the role. Please create a role so I can stop your EC2 instance, right? So for that one, we have to create a role in the Lambda function that gives Lambda functions access to the EC2 instance. Then when the Lambda function proceeds to stop the EC2 instance, it will happen, okay? So that's basically the role of a role, okay, to give permission to a service to interact with another service. We use a Lambda function to automatically make API calls to other AWS services when scaling happens. For example, we have an AWS Lambda here, okay? So we have here some, compatible SDKs, right? Node.js, Java, Python, SDKs stand for Software Developer Kits, right? And then AWS service via API, okay? So we can do this. But you have to see an example for you to have an idea how it works, right? It's very, very easy to see it. I mean, it's but you have to understand it, right? How can AWS Lambda be used scaling? How can AWS Lambda be used scaling? This is not correctly worded. Okay, so it's examples of scaling related operations you could perform with AWS Lambda. Scale container-based instances, Docker, Amazon Elastic Container Service, etc. So increase or decrease, scale more intelligently using functions. Example, analyze a stream of performance data looking for patterns rather than just events, right? And since AWS Lambda can scale automatically, consider replacing some Amazon EC2 instances with Lambda. That's exactly what I told you before. The trend is to replace EC2 instances with Lambda, because Lambda automatically scales. EC2 instances don't, right? You need auto-scaling, which is an extra step, right, for your EC2 instances, whereas for Lambda, it automatically scales, so you don't have to worry about that. Okay? So, part 2 review. We explore the best practices of scaling and when it is appropriate to use scaling. Review the benefits of auto-scaling. Describe data store, AWS Lambda, and event-driven scaling. Next class on Wednesday, we're gonna see how we can automate our infrastructure. Okay, now that we have created it, now we have to automate it, okay? And that's the purpose of the entire AWS thing, to automate things that we have to work less, right? We work less, we configure more, we work less, we make more money. So we have to automate things, right? And let's focus on business, on making our customers happy, right? On business models and business things that make our business much elegant, efficient, right? And forget about the automation. Is already taken care of. Now, I have to warn you, automation gives you a false sense of confidence, okay? So even though things are automated, right, you have to be careful and not just forget about it. You have to check it every now and then, make sure that it doesn't break, right? Because when you think it's automated, you think, oh, it's done. Let's worry about something else. That this is no. We have to consider that things break, right? And things may not work the way we want, because nothing is perfect, right? Okay, so the lab. So in the lab, you will add another AWS Lambda function to an auto-scaling group. This function will automatically tag and create a snapshot of any new instance launched into the group, right? Here are the services that you will use. Amazon SNS, auto-scaling, AWS Lambda, AWS IAM, Amazon EVS snapshot, Amazon CloudWatch. So this is gonna be a heavy-duty lab, right? Heavy-duty lab. So we have Amazon SNS for notification, right? Auto-scaling for scaling in or scaling out your EC2 instances. Lambda to do an action, to take an action when it's triggered by an event. AWS IAM to create roles so that services can interact with each other. Amazon EVS snapshot, you're gonna create Amazon and you're gonna store them in an S3 bucket. And then you have like the heart of this architecture, you're gonna have the CloudWatch, Amazon CloudWatch, which is the one that's gonna orchestrate all things together, okay? So first, you're going to create an Amazon SNS topic, configure autoscaling to send events, create an IAM role for the AWS Lambda function, create an AWS Lambda function, trigger autoscaling to scale out, and test the result. Okay, good. This is the final product. All right, our autoscaling group here, right? You're going to have a snapshot store in an S3 bucket. Then autoscaling launches new instances here with autoscaling, right? Autoscaling notifies with SNS topic, right? Amazon SNS triggers a Lambda function, right? And the Lambda function saves the logs. I mean, you're going to save the logs in Amazon CloudWatch, right? So Lambda function sends logs to Amazon CloudWatch logs, right? This has to be a role, right? There has to be a role in the Lambda function. So Lambda function can do all this, right? Okay, Lambda function is going to interact with the EC2 instances, right? So it needs a role. If there's no role, nothing is going to happen. Nothing is going to happen. Okay, so the labs are well explained, right? They're well explained. It's a step-by-step process. It should take you no more than 30 minutes, right? But if you just follow the steps and you do it, everything goes well, uneventfully, you should end it in less than 30 minutes. All right. So do you have any question?
Which lab number is this?
Lab number, sorry, lab number is 3.
Okay.
Okay. Let me show it to you guys in Vocarium. All right. So the class is Cloud Architecting, and then assignments. So we're gonna come to lab 3. Okay, making your environment highly available. So in this case, I cannot see because I logged in as a professor. I'm gonna log in as a student. All right. And then we have here, this is for the morning class. Okay, so we have here lab 3. Oh,
that's Cloud Found. Yeah.
Okay, sorry. So we have here lab 3, making my infrastructure more available, highly available. So okay, so remember, this includes our past class and this one. Okay, so you're gonna do all this, inspect your Amazon EC2 instances, log into your Amazon EC2 instance, and then you're gonna use SSH for that. You see exactly what we saw this morning, not this morning, at the beginning of the class. Okay, so you're gonna work on that. You're gonna install HTTPD, PHP, right? And continue here. Create an Amazon image, configure a second availability zone, create a second public private subnet, second NAT gateway. Okay. Load balancer. Okay. Test the application, right? I don't think the explanation of the PowerPoint matches this. That's why I'm always telling you what is the PowerPoint changes all the time. Actually, not the PowerPoint, the platform that AWS has, but nothing new. We saw all this in class. I mean, all the concepts we saw it in class. What you have to do is follow the steps and don't do it blindly. Just try to understand. Try to understand the concepts behind it. Okay, that's what you have to do. And I believe that. Let me see something here.
Where do we find this?
This is the one that let me see this one. This is the one.
This is the one that we should be
This is the
doing.
one.
Go ahead.
So the problem is that we have to do lab 3 and 4. Okay, we have to do 3 and 4. Is this not, this is lab 4, right?
This is 4.
Okay, we have to do 3 and 4. All right. So this has to do with our first section 1, and this one has to do with section 2. Okay, and this one has to do with the one that we are doing next class, the automation, and this is when we're going to see CloudFormation. Okay, so guys, try to do as much as you can. Lab 3 and 4, they are available right now. Okay, they're both open. Okay,
How do we access it?
how do we you go to labs that it should be in your Google Classroom. The link is there. The link is there.
Okay.
Okay, so you're gonna do 3 and 4. Okay, 3 and 4. Okay, you can do 3 today, you can do 4 tomorrow. Try to do them before the next class. Okay, so things don't pile up.
Do we do this? There is something called sandbox here. Do we do
Yes.
this in the sandbox, or do we do it in our own
well-
AWS account?
No. When you do this, and then you do my work, there's one section there that says Star Lab. Okay, it gives you the instructions here. You can start the lab and then AWS. It will take you to the AWS platform. Okay, you can use the sandbox, right? Okay, the sandbox.
I have never. Sorry, I was talking on muted. Muted. I have never used this, so if you can.
The
give me-
sandbox is for practice,
Okay.
so you don't have to use your account. Right?
So I'm sorry, we don't use our account, yeah?
No, you don't have to use it. You don't have to use it. This is all AWS. Okay, so AWS is giving you the platform for just about a month or so until the class ends, so you can use their platform. So this is just in case you want to practice. But when you start the lab, for example, lab 3, you're here and just start the lab, right?
So when you start the lab, it actually gets you into the console or whatever you need to go to do this, or?
Yeah, it says here at the top of these instructions, click Start Lab to launch
okay.
your lab. A tab level lab panel opens displaying the lab status. Wait until you see the message lab status ready. Then click the X to close the Start Lab panel. And at the top of these instructions, click AWS. This will open the AWS Managed Console. You see? This is a Start Lab. When it says ready here, it says in creation now. Okay? So I have to wait until it says lab is ready. Then I close it here, and then I click on AWS. All right? And it will take you to the AWS console, but it's an account that is created for you guys. Now, what are we doing here? Can you take a look at the ARN? Can you take a look at the ARN? What does it say here? What does it say here?
CloudFormation.
It's using CloudFormation to create your lab. So AWS is using AWS resources to create your lab.
Of course.
That's super amazing. That's amazing, huh?
Yep.
Mm-hmm. Amazon is using AWS too. 2 different companies, same owner, but 2 different companies.
So
Amazon.
how long does it take for this lab?
It depends on how long it is.
Mm.
Okay, it depends on how long it is. Okay, so I'm gonna close this. I don't need this. But when you click on AWS, this will open the management console.
The AWS that you're talking about is the one on the upper right-hand side. That one. Okay, got it.
Yeah, and it's not your account. is AWS creating an account for you, a temporary account.
So it's a lab account.
Yeah, that's going to be closed. The account is going to be destroyed or eliminated when you close the lab. When you end the lab, everything is lost. Everything is gone. Okay? This is something temporary for you to work on the lab. Now, if you want to work on the lab again, then you have to go through the same process. And then it creates the lab for you with different resources, a different EC2 instance, a different auto-scaling group, or whatever. I don't know. Whatever they're just creating behind the scene. Okay?
So this will be good for recording. What's a good recording screen application? Screen recording application.
What do you mean?
So if I want to screen record as I go through this, so I can review